Okay, this is question 6 from the 2018 WJC additional maths paper. So the first thing to notice is that this is a written communication question. So you have to be clear in everything that you write, make sure that your units are there throughout, and try and make sure that everything you write is in an ordered manner and it's clear that, and your method is clear throughout. It doesn't mean that you have to write lots and lots and lots, it just means you have to be clear and concise in what you're doing. So, first of all, we have a diagram here, parallel sides there, and another pair of parallel sides there. So that means that this is a parallelogram, which we are told. And we are looking at finding the area. But more importantly, you're told that you must not use your calculator. Okay, so that's going to make it slightly more challenging. But you have to make sure that happens. So let's have a look at the parallelogram in centimetres squared. Now, the one thing we do know about a parallelogram is that the area is base times height. So if we could work out this perpendicular height, then we could work out the area. Now let's have a look what we've got. We have 8 centimetres here. We have this angle, so we could work out the height. So we could use normal trigonometry. Another way we could do it is by splitting here, and we have 2 identical or congruent triangles. And we can maybe work it out that way. I am going to go with the normal SOHCAHTOA way. So if I drop a vertical line in here, so it's called dropping a perpendicular because it will be perpendicular to the base. Let's just move it across. So we're looking at this. We know this side here is 8 centimetres because it's a parallelogram. And we're looking for this height. So we are going to use, what's our opposite side? This is hypotenuse, pointed to by the right angle. This is the adjacent. The adjacent we're not looking for, and we don't know what it is, so that's a bit pointless. So we're using O and H, which is our sine ratio. So, the perpendicular height, which is the height that's at a right angle, is the parallelogram. So I'm just going to put that as a little side heading. I find when I'm trying to be organised in my communication, using little side headings works out well. So, we've got this diagram. Where that's 60 degrees, that's 8 centimetres, and this is what we're looking for. So we can say sine of 60 equals the opposite over the hypotenuse, so that's x over 8. And that then becomes, by multiplying that by 8, I get 8 times sine 60, or 8 sine 60. Now, it's all well and good, but I need to do this without a calculator. Now, this sine 60 is one of the values that WJC expects you to know without using a calculator. In reality, they got no idea whether you use a calculator to work this out or not. So if I went to my calculator here and typed in sine 60, I get root 3 over 2. Now, there's no way of telling whether I use my calculator for that or if I actually knew the value. In an ideal world, you learn those values. If you don't, if you can't remember them, you could always go about it this way. So this becomes 8 times root 3 over 2 is our value of it for the height. So that is 4 root 3. And it is in centimetres, so 4 root 3 centimetres equals x. Okay, now I can find the area of the parallelogram. So the area of the parallelogram We know the formula is area is the base times the perpendicular height. So the base we have here is 17, and the perpendicular height is this x. So it is 17 multiplied by 4 root 3. So 17 times 4 is 68. So we have 68 root 3, and our units were centimetres, but because this is area, we have area squarea, so centimetres squared, and that would be our final answer.